Have you ever wondered what the universe is made of, or pondered the building blocks of matter itself? Well, today, we delve into the fascinating world of subatomic particles, focusing particularly on one of the most intriguing of them all, the neutron. The neutron, as the name suggests, is a neutral particle. It carries no electric charge, distinguishing it from its charged counterparts, the proton and the electron. Neutrons, alongside protons, make up the nucleus of an atom, accounting for a whopping 99.9% of an atom's mass. Quite hefty, wouldn't you agree? But what exactly is a neutron made of, you might ask? Well, neutrons, like protons, belong to a family of particles called hadrons, which have an internal structure. They are composed of smaller particles known as quarks. Specifically, a neutron contains 2 down quarks and 1 up quark. These quarks are held together by a force aptly named the strong force, one of the fundamental forces of nature. Now, here's a peculiar trait about neutrons. They don't exist freely in nature except in cosmic rays. When outside an atomic nucleus, free neutrons undergo a process called beta decay. They break down into a proton, electron, and an antineutrino, a process that's a cornerstone of the field of radioactivity. Another fascinating aspect of neutrons is their interaction with matter. Unlike charged particles that are deflected by electrical fields within atoms, neutrons pass through. They interact with matter through collisions with atomic nuclei, making them indispensable in many scientific experiments. To top it all off, despite their neutral charge, neutrons aren't completely devoid of magnetic properties. They possess a magnetic dipole moment, behaving like a tiny magnet. Quite surprising, isn't it? In a nutshell, the neutron is a neutral subatomic particle, heavier than both protons and electrons, and forms the bulk of an atom's mass. Composed of quarks and bound by the strong force, neutrons are fascinating particles that undergo beta decay when free. They interact with matter through collisions and possess their own magnetic moment. Understanding neutrons and other subatomic particles is not just about satisfying our curiosity. It's about unlocking the secrets of the universe, about understanding the fundamental nature of matter. So the next time you look up at the stars, remember, you're made of the same stuff as them, a beautiful and complex arrangement of subatomic particles.